For problem number 1 of tin ball pressure vessel, a cylindrical steel pressure vessel 400 millimeters in diameter with a wall thickness of 20 millimeter is subjected to an internal pressure of 4.5 megapascal. So, first question is calculate the tangential and longitudinal stress in the steel. So, ang sabi daw, meron daw tayong cylindrical pressure vessel with a diameter of 400 mm. Then, ang wall thickness niya daw is equivalent to 20 mm. Then, meron daw tayong internal pressure P equivalent to, so sabihin natin ito yung ating vessel. So, meron daw tayong pressure equivalent to equivalent to 4.5 megapascal. So, yung pressure natin is equivalent to 4.5 megapascal. So, first thing you should do, syempre, is i-drawing muna natin. So, pag dinrawing natin yan, so, pag hinati natin yung tank, di ba? Paano natin hati? So, dito. Pag hinati natin yan, so, ganito yung itsura niyan. Then, masyado atang maliit. Ayan. Hirap mag-drawing. So, dito, meron tayong force F. Tama? Then, ang nagre-resist sa force F is yung force T. So, ito is force T. Din sa abila is force T din yan. Diba? So, by summation of forces along horizontal equals 0. So, 2T is equivalent to F. Tama? Where F is equivalent to P times D times L. And yung T natin is equivalent to, so, ito parehas is equivalent to S equivalent to P divided by A. So, yung P lang dito is yung F. So, sa first equation. Then, yung P naman dito sa second equation is yung T. So, pag tinranspose mo kasi yan, magiging P equivalent to AS. So, ito yung stress which is P. Then, yung area which is diameter times the length. Then, for T naman, so, sa T, mangyayari, so, ang stress natin is yung stress ng tank. So, stress T times thickness times length. So, 2T, so 2 times stress T times T times L is equivalent to P times D times L. Then, next, by rearranging the equation, so, ang mangyayari, so, pag dinerive natin yan, so, stress T is equivalent to P D divided by 2T. So, stress T is equivalent to P. So, ilan yung pressure natin? So, ang pressure natin is equivalent to 4.5 megapascal. So, Newton per mm squared times D. So, kung D natin, diameter is 400 mm divided by 2 times T. So, ilan yung thickness ng ating wall? Ilan tong thickness na to? So, ang sabi, 20 mm. So, 2 times 20 mm. So, ilan yung ating tangential stress? So, 4.5 times 400, 2 times 20. So, ang ating stress is equivalent to 45 megapascal. So, ito is equivalent to stress tangential. Then, next, punta naman tayo sa longitudinal stress. So, for longitudinal stress naman, so, pwede rin naman direct equation na. However, derive lang natin. So, for longitudinal, so, di ba, meron kayong cylinder dyan, which has a thickness of 20 mm. So, ito yung thickness natin, di ba? 20 mm. The next diameter natin is this 400 mm. Tama? So, ang sabi, so, dito, meron tayong force T. Then, dito naman, so, pag ganun, so, yung kanina, yung force P natin, pag ganyan. So, yung force F naman natin is pag ganun. Force F. So, ayan. So, next, so, by summation of forces along horizontal is equivalent to 0. So, P is equivalent to F, where P is equivalent to stress T times pi d T. So, stress T is the stress, then pi times d. So, hindi natin is diameter ng tank, and T is the thickness of tank, equivalent to F. So, yung F na natin is pi divided by 4, ito yung area, times d squared times P, internal pressure P. So, by rearranging this equation, so we can resolve to this final equation. So, stress L, which is longitudinal, equivalent to P divided times D divided by 4T. So, yung internal pressure natin is 4.5 times 400 divided by 4 times T, 20. So, ilan yung ating longitudinal stress? So, 4.5 times 400 divided by 4 times 20. So, simply 22.5 megapascal. So, ito na yung longitudinal stress. 22.5 megapascal. And that's it for problem number 1.